Hi guys, today we're going to go ahead and we'll look at section 3.3, which is solving systems of inequalities by graphing. So far we've just been looking at systems of equations, so now we're going to go ahead and put in inequalities. So your learning target for today is that you will be able to solve systems of equations by graphing. So we have an example here. During one heartbeat, blood pressure reaches a maximum pressure and a minimum pressure, which are measured in millimeters of mercury. It is expressed as the maximum over the minimum, for example, 120 over 180. Okay. Normal blood pressure for people under 40 ranges from 110 to 140 millimeters for the maximum and 60 to 90 millimeters for the minimum. Okay, so we want to express this as a set of inequalities. Well, if I just let my maximum represent my x-axis, and my minimums represent my y-axis. Okay. Well, my x values, well, it ranges from 100, so it can't be less than 100, so it has to be greater than or equal to 100. But then it's to 140, so it can't be over 140, so it has to be less than or equal to 140 for my x or my max values. Then for my min values, it's from 60 to 90. Well, that's my y value. To be from 60, so it can't be any lower than 60, has to be greater than or equal to 60, and then finally 290 has to be less than or equal to 90. So this would be my systems of equations, and if we wanted to go ahead and graph this, we would get a graph that looks like this. As you can see, my maximum pressure is my x value, okay, and it ranges from 100 to 140. And then my minimum is my y values, and they range from 60 to 90. So from 60 to 90. And so if I wanted to find out where all my possible solutions are, it's going to be where everything is shaded, which will be in the middle. We're going to go ahead and look in just a minute at another example. So Classy Catering needs at least 15 food servers. Okay, at least 15 food servers and 5 bussers to cater a large party. In order to make a profit, they can have no more than 50 food servers and 7 bussers working at an event. Write a system of inequalities that represents this. So I have to think about the two things that I'm working with. I have bussers. We want to have the number of bussers. And I have servers. So S will be the number of servers. So let's just go ahead and look at bussers. Well, it says it needs at least 5 bussers. So that means that B has to be greater than or equal to 5. And then if I read the next part, they can have no more than 7 bussers. So bussers has to be also less than or equal to 7. Then if I go ahead and look at servers, they need at least 15 servers. So it can't be any less, so it has to be greater than or equal to 15. And then it also says they can have no more than 34. So the servers also has to be less than or equal to 34. So this would be my system of equations to represent this situation. So let's look at a graphing problem. We love graphing. This one is going to be just solved by graphing. That's how we will solve these systems of inequalities. So I look at my first equation. I'm going to do it in green. And if I notice it's greater than or equal to, so right away when it's equal to, I know it will be a solid line. Okay, so in order to graph it, I start at my y-intercept of 4. And then my slope is -2. So that means I'm going to go down 2 to the right 1, down 2 to the right 1. And once again, I recommend doing the dots all the way across the graph. And it's a solid line, so let me go ahead and connect that. And then it says y is greater than. So do you shade above or below? Well, for greater than, we shade above. Okay. So now we're halfway done with the problem. I'm going to go ahead and graph the other line, and I'm going to do that one in red. This one, once again, is less than or equal to, so the equal tells me that it will be a solid line. So I see that my y-intercept is -2, so I plot -2. Then I see that my slope is 1. So it means rise 1, run 1, rise 1, run 1. Then we go ahead and draw this line. It's, like I said, solid. And then I look, it says y is less than. Well, less than, I think lower, so I think below. Now here's the trick with my systems. Your answer is wherever it is double shaded. So double shaded equals the solution region. So in this case, we are double shaded right here. So this is my solution region. Example 3, I look at that one. We also have to solve it by graphing. Well, we have an absolute value is less than 3, so we have to think back to absolute value. Well, when we solved equations with absolute value, we just solved it as is. So my other equation is y is less than 3. And then to get the other part of the equation, we would flip the sign and change the sign on the 3, so negative 3. So I just rewrote this absolute value equation into these two equations, so it's easier to graph. So really my system involves 3 equations. Here they are. So I'm going to start with graphing the first one, and I will do that in red. And it's y is greater than or equal to. So once again, this will have a solid line. Start with my y-intercept of -1, and my slope is 1. So rise 1, run 1. And this is a solid line. And it says y is greater than. So greater, I shade above. Then I go ahead and I move on to the next one. I'm going to do this one black. It's less than. There is no equal to, so remember that's a dashed line or dotted, whichever one you want to say. So y is less than 3. You have to think to yourself, well, what is a y equals equation? That is a horizontal equation. So it's where y is 3. So I do that, and it's... And this one says y is less than 3, so I'm going to shade below. And then I'm going to go ahead and do y is greater than -3 in blue, and this is not equal to again, so it's going to be a dashed line. Horizontal line at -3. And once again, it says greater, so greater means to shade above the line. So I'm just going to shade where it will be double. So where I put the blue shading, that is my solution region for this problem. Let's go ahead and look at number 4. I would like for you to graph number 4 on your own. Pause the video and graph number 4 on your own. Here is the solution for number 4. Notice it is in green. So check that over. We can go over questions tomorrow in class. Then if we go ahead and look at number 5, this one looks different, I notice, when I look at it because it doesn't say y equals. So what I recommend is putting it into slope-intercept form. So I'm going to take this one. To put into slope-intercept form, remember that's y equals mx plus b. So I want to get y by itself. So I would subtract x to the other side. So I have -y less than or equal to -x minus 1. And then I would divide by -1. The biggest thing you need to remember here is that when you divide by a negative, your sign needs to flip. Okay, so now I can go ahead and graph the top one. Let's look at the next one. We're going to take care of this one. So we have 3x minus y less than or equal to 4. I would also subtract 3x. So I have -y is less than or equal to -3x plus 4. Now I'm going to go ahead and divide by a -1 again. Once again, I'm dividing by a negative, so my sign must flip. So it's greater than or equal to 3x minus 4. I would like for you to pause the video, and I would like you to graph these two equations and get this system of equations solution. Once again, I went ahead and put the solution for number 5 up. It is the shaded area in green. Please make sure you check your answer, and we'll go over any questions in class. Then we have one last problem. It says find the coordinates of the vertices of the figure formed by the systems of inequalities. So we're actually not going to do the problems listed on your note sheet. We're going to change it up. I want to graph the following 3. Y is less than 3 minus x. y is greater than or equal to -1, and x is greater than -1. Okay, so let's go ahead and do this. The first one, I'm going to graph in blue. My y-intercept is 3, and my slope is -1, so I go down 1 to the right 1. Or my other option is I go up 1 to the left 1. And that should be a dashed line. So make sure you do that. Dashed line. This one is less than, so y is less than, so shade below. Then I'm going to do the next one in green. And this one will also be, this will be a solid line. Y is equal to -1. That is a horizontal line. So at -1, I'm just going to have a straight horizontal line. This one says y is greater, so I'm going to shade above. And now my last line, I'm going to go ahead and do that in red. And this will be a dashed line because there is no equals. X equals, that is a vertical line, so up and down, and it's at x is -1. So here's where x is -1, so I just go straight up and down, except for it is dashed and not a solid line. And then it says x is greater than -1. Well, 0 is bigger than -1, so I'm going to shade this way. Where I have the red is actually where it is the solution, so in this area where I'm going over with the purple. So what it wants is the vertices of the figure formed. Well, the figure formed, I hope you can see it, is a triangle. And the vertices, well, this point right here is -1, -1. Up in the far right, we have 4, -1. And then my last one at the top, I have -1, 4. So there is the vertices of my triangle. We are going to go ahead and stop the video there for today. So I will see you tomorrow in class. Let me know if you have any questions.